I'm super excited to be here. FYI, I like participation. You know, it's fun. The recording will miss out. When people see this on the computer, they'll think like, what the heck is going on? But we'll all love it. So, did you know, actually, that this is my second time speaking at the Big Elixir? Yeah, there I am. On the same stage, 2018. I know it's hard to believe. I mean, look at this difference. In fact, I was going to let my hair down. That definitely can't be the same person, right? Okay. That was my first conference talk, actually, I had ever given. And the Big Elixir got in on the ground floor. To the mayhem that comes out of my mouth, recorded on video, and forever stored on YouTube. So that will forever be their credit. Thank you, Big Elixir. Yeah, there we go. But I bet they regret it every year, to be honest. But it's too late, no take-backs. I'm already here. So let's get tipsy with nerves. But it's not what you think. All right, this is a tech conference. Maybe calm down a little bit. You see, the nerves team really wanted a way to communicate small blurps of helpful information that users run into all the time, but sort of kind of get buried in the documentation or in the implementation. It's just not always known if you don't do it all the time. Also known as tips. But then we thought, how do we deliver these tips in a nice and jestful way? So we started looking at the latest technology and decided because we're a bunch of developers, it's got to be Twitter. That's what we use. And maybe a website that kind of backs it up and does a little more from it. So the natural step is to pick a stack, decide what to do it in, and because I'm not really good with web development, which seems to be an interesting theme here, I just chose what's super hot right now, right? And so I set off on this venture and made this first iteration of the website. Has anybody ever been there? Does anybody know? Yeah, okay. All right, cool. I mean, it's Twitter-esque. And here's a cool little admin page. I mean, this is live view stuff happening. That's kind of fun. But really the most important thing is I think that it's in here. Yeah, that one, yep. Light and dark mode. That was, in fact, the very first feature that went into this website. I spent too much time that I should even admit trying to get it to work. But this was nice. I used Tailwind. That now does precompiled binaries with ESBuild as well, which is super fantastic. I don't have to deal with Node. I'm already familiar enough with Phoenix and Versa.enough and the Twitter sphere. And like as we said, with anything CSS, I wasted way too much time. But I just recently discovered that this was all moot. With this simple piece of code provided by Twitter and their integration website, it will build the entire card for me. Wow, this is dark. Should use a light mode. Yeah. So you can't even tell, but this is the tweet. It's got the replies, the likes, the introspection, even the share it button. So basically, I don't know which reaction to have, if I'm being totally honest. And this talk has very little to do with live view. So, except you can definitely run Phoenix and LiveView on Nerves devices. We have examples that outline this process. You can even just copy it directly. It's totally nice and easy. And it's incredibly useful at times. And this is totally the organizers in the back right now. Really, really questioning their decision to accept my talk. Yeah, that's the regret settling in. But this presentation is definitely about nerves. In fact, there are quite a bit of tips in this presentation about nerves. No pressure. Try to keep up. There will be a quiz. So let's get into it. Anybody use nerves? Anybody? We got a few. Anybody professionally use nerves? Okay, a couple. So this is going to be really boring for the rest of you, maybe. So sit tight. Maybe we'll keep it enjoyable. But let's quickly define it. A super review. How about anybody go to Nerves Conf? Yeah. All right. Take a nap for 5 minutes. It's going to look really familiar. You know this because you remember everything I said there. So according to the documentation of Nerves, it is a platform a minimal system that boots directly to the Erlang VM. It is a framework, ready-to-go library of Elixir modules. Put your code in there, interface with it. Really neat. And tooling. It's so much tooling for cross-compilation, firmware bundling. The whole goal is to make working and embedded on the Erlang VM effortless as possible. And at the core is Erlang, Then we include the Linux kernel, but only the Linux kernel, not the whole system, just the scaffolding that we need to do for this process management. And an Erlnet shim connected to the Erlang runtime just kind of connects the user LAN bits and pieces and stuff to really get into Linux. And that is some build root, and after that, build root stuff. Has anybody heard of build root? Probably. It's kind of foreign. You don't really need to know, but we've got a couple. Native libraries, apps, hardware-specific board details, and then you have your Elixir and Erlang projects and all its dependencies. Like, if you do anything with nerves, this is probably where you would spend 90% of your time. And all the application code gets bundled into an OTP release, and all this gets collectively bundled into a firmware file that we then burn to an SD card. And this SD card setup is typically in 4 partitions. We have the U-boot environment, very small space for persistent key value storage across reboots, usually used in the boot process to determine some startup pieces. We have the boot partition, naturally, because we've got to start somewhere. And then we have a root file system that the Linux kernel nuts and bolts needed to actually go in. And then we have this application partition. And this is where you put specific data for your application or device, whatever you're running. In fact, this is the only writable portion, the application partition, of a NERV's firmware and system running. And so we typically expand that out to whatever the rest of the size of the memory is. And NERV's takes all this further with AB partitioning scheme. And if you're not familiar with that, what this means is that the boot and rootfs partitions are actually split into 2, an A and a B firmware. And only one of those is active at a time. So the next update will overwrite the other non-running partition, leaving the previous setup intact, which is super great because you might update and discover that you have some rogue gen server message in the wild and really mess things up. And then the finger pointing begins. But fret not, because of the AB partitioning setup, you can call nerves runtime revert, nice little helper function, and go back to the previous partition, which is pretty nifty safety net to have. Now, I could probably spend a whole conference talk on just that. In fact, wink, wink, maybe that'll come. There are many protections that you can do. Sometimes you can't go through this manual intervention, but just know that there are lots of avenues to help integrate with this AB setup to really get more fault tolerance. So with that out of the way, let's play a quick game. Can it nerves? But you guys are going to do great, because everybody, is using nerves in here. So, didn't take my finger press. Does anybody know what these devices are? Do you recognize them? Can you nerves these? Can it nerves? Yes? No? Yeah, I would hope that you get that one. It's kind of a bread and butter. All right, let's mix it up. How about these? Yes? Yeah? Okay. Like general consensus? Yes? All right. Maybe a little bit harder. Anybody know what these are? Oh, no. Can't. These are little Arduinos, microprocessors, are not capable of running what we need on them. How about this one? We got a yes? You try it? All right. Yeah, this is a real stumper, isn't it? This is actually a yes. So this is the same processor that many of the BeagleBones use, just on its own custom breakout board. So the trick to this is really not can it nerves, but can it Linux. When you're evaluating a processor and the ability of which to run this tooling and project on it, you need the processor's ability to run the Linux kernel. If you have that, you can run nerves on it. There might be a lot of work, just depends on what you're doing, but technically the answer can be yes, theoretical. So let's shift gears and talk about accessing nerves devices. So how many of you have gone through installation, you burned a firmware, and then realized that these things need USB, and you have to trudge through the box of adapter hell, and then you finally get it plugged in with a little bit and see some blinking lights, and that's pretty exciting, but what do you do with it now? All right, well, for many of you, like any good developer, you grab a monitor, you dig through the same box for a keyboard, and then you plug it in, you get some screen, bam, this works great 90% of the time if you can find your extra stuff. But, oh, no, go back. Some devices don't have HDMI. Or maybe they have HDMI, but we've disabled it by default. Man, you can't even see. Okay, look at this commented out line down at the very bottom, the -C HDMI input. Just trust me, it's disabled. So when you try to use it, and you plug in a screen, you plug in a keyboard, what you actually see is a whole lot of nothing. And wait, we also set the LED trigger of the heartbeat, or the LED trigger to heartbeat, because the default really isn't useful to us. It's about micro SD card access, usually with Raspberry. And, but that heartbeat pattern also looks an awful lot like these error patterns reported by Raspbian OS. So we turn off your way to see a screen, and then we make it look like it's broken. What? But don't worry, it's okay. There's a reason. It's a good reason. So you see, these devices in particular have USB OTG. And this allows us to do USB Ethernet gadget. There's a lot of words in there. Oh, shoot, no, go back. Abort. Whatever, this is where we are. Don't get too focused on the Ethernet. What we can do is that we can actually connect these USB ports to the machine, make these devices appear as an Ethernet or gadget device, and then get access directly to a link connection with the device. And this opens up local networking via USB, and this allows us to do things like SSH directly to the device. So there's actually no need for that extra monitor or keyboard anymore. Just keep that plugged away. And SSH is, in fact, the easiest and most preferred way to access these devices once you get things set up and are trying to play around. Although it is worth mentioning that you can use FTDI serial cables like this, connect them to the UART pins of your device, and use your terminal emulator of choice. For me, it's PicoCom. It's super enjoyable. And then you can access the console of your device through a serial connection. And this is technically easy. It does require some configuration, knowing the pins. You always got to swap the TX and the RX 10 times because it's like USB. You always get it wrong the first time. And it needs some extra configuration in some cases. So that said, let's go back to SSH, specifically Nerves SSH. And maybe some of you have gone down this realm and you might say, John, there's so many SSH clients and daemons in Elixir. Why would you make another one? And I would say, good point. However, we fielded a lot of those, and we just decided that some of the things were just too generic and broke or really messed with some cases we needed. And so we ultimately decided to make a daemon or SSH daemon library just specific to the context of Nerves, and this is where you would want to try to primarily use it. So one of the ways that you can configure this, if you're so interested now, is by adding some authorized keys to your config file. And here you just see we kind of look for all the basics, the generic names when you just hit enter a bunch of times, creating a new key. And this is actually from the default mix nerves.new generator. So you can see that coming in there. You can also configure using passwords for SSH access, which maybe isn't the most secure to keep in your application config environment, though it's super convenient when you need to do lots of fielding work and testing and maybe more for development cases. We should also note that Nerves SSH is only started when there are application config values. So if you were to take away all of this, then that opens, the library will skip trying to start it, and you can put SSH into your own supervision to allow you to control the start-stop of this access daemon, and it's really just giving you the full power of access control on your device, which is useful in cases like at SmartRent, where we want devices that we want to have SSH on, but we don't want it to start by default, but we want to be able to start it. And so we typically, in these development organizations, will include everything we need in there, and then via Nerves Hub remote console, we'll try to go in, we'll add some application config values, and then we'll just stop and start the Nerves SSH app, and then we have access for this one session until reboot on the device. Oh, Nerves Hub uses live view. That counts, right? Yeah, that's where we say yes, yep. Maybe a clap, there we go, yeah. That has live view. That's pretty much it. Another option is configure some access settings at runtime. This one's a little bit longer, but this is a blurb of, first I gotta show you how I can access a device. Then I'm gonna paste in some cool, really awesome public SSH key. Don't bother trying to copy it. And then that should go through, right? Okay, cool. You can also add a username and password from a running session at runtime if you just need to allow somebody some quick access. I feel like I really should have sped these up. I must also type really slow. I mean, this is used for cases where you want a generic default login, maybe. But when the firmware is deployed, you might want to just change it later and not keep relying on that default. And so, since we now have access to this device via SSH, let's talk about some of the cool things you can do with it. Like SSH escape sequences. Here I just sent the ~? to see what's available. And you can play around with these on your own, but because you're in this SSH session, you do have access to these technically. And maybe the most important one that you should commit to memory right at this moment is the terminate connection command, ~. And that will just obliterate any session you have. It's super useful if you've yanked the connection to your device, it shut down, it's just no longer around, and your SSH session is still in there. You blast this bad boy in there, and it'll be no more. And one more important thing to remember is this line says, note that escapes are only recognized immediately after a new line. Well, when you have an IEX console session open, you don't always have a new line directly next in the past history. So you kind of just, it's useful to just slam the enter key a few times like I instinctually did right there. Oh, and another fun thing is when you're in these sessions, it's not only do you get IEX history by pressing the up arrow, but you get the Control-R recursive history search function. And so you can actually look for that super long convoluted argument function you used one time, but only remembered maybe the atom argument. And how about if you need to make change to code on a device? You don't want to bundle a whole new firmware, right? Well, you can just copy pasta that stuff right in. And I am not ashamed to admit I do this all the time. Okay, we're going to see it work. Yeah, isn't that fun? It's especially cool because this is a read-only file system, so this is all in process. Nerve SSH also supports SFTP, if you like using that, I guess, to send files, get files, do whatever. There's actually more detailed information about using these remote file situations. I don't know, I'm blanking on the word. If you can even read the bottom line there and really type that in super fast right now. And then I'm just going to skip through that part. You can also use SCP. That's kind of a bread and butter when you're working in the terminal, right? That's super convenient. In this case, I've SCP'd a file from the device onto my host. It's super nice. One other cool tidbit about this remote access is this section right here. In fact, specifically this portion, we stripped the beam files to keep firmware size low and consolidated, but if you use this fun little argument there, you actually get to keep documentation within your device. So if you want to get a quick read on some documentations in IX on device, you can totally do that. Oh, and look at this. Oh yeah, right on cue for the next tip. Remember that fancy screen we keep seeing from the SSH session? That's called Nerves Message of the Day. Getting very nervesy, huh? Or MOTD, or MOTD, however you want to say it. It's included in the generated ix.exs file and is customizable, as we just saw in the docs. So if we were to play around with this a bit, you can specify a new logo to your liking, maybe something like really classy. Or you want to add a new line into here. I forgot I did this. This is going to be wild. Hold on, there it is. Here it comes. So, there's a lot of curly braces and brackets there. It's kind of its own structure to add rows. But it works. See the cool little yellow line down there? All right. Okay. Yeah, that's, okay. I guess that's clap-worthy. Cool, cool, cool. So while we're sitting in the IX prompts, let's talk a little bit about Toolshed. Does anybody use this? Anybody know about this? I'm about to blow some minds then. Okay, so how many of you have been instinctually typed a command right after you enter in an SSH session? You just SSH some machine and boom, before it's even come up, you've typed something. Anybody? Is that only me? Okay, I thought there was going to be way more. So imagine that you SSH to this Nerves device, and then you just blam in this LL command. That's usually one of my go-tos. Just, I don't know why. Where am I? I mean, dirt, it doesn't know what to do. This is IEX, not a self session. So some shell commands are just so useful that we need to have them. And when they're not there, like, what do you do? Is there an Elixir way? Do I have to write a new function right now? How do I even just see what's in my directories? I don't know, but you're in luck because that's exactly what Toolshed is for. Think of it like an Elixir wrapper for some command line useful functions, and especially ones useful in hardware contexts like grepping a file with some neat little regex. Yeah, that's fun. Or lsmod. See what kernel modules have been loaded into your hardware. Especially useful when you're starting with new devices. Or dmessage. Anybody use this frequently? No? Okay, well. Print some kernel messages, especially when you have to deal with the Linux kernel all the time. Super useful. And tree. This is actually one of my favorites. Just see what's around. What files do I have? What's existing on here? Give me a visual breakdown. MSLOOKUP, I use this all the time, especially on devices that are on an unknown network, and I just need to know if something exists around there. Or classic ifconfig. Everybody uses this. Yeah, okay. Yep. You can also ping things. Ping is especially cool because you could ping just a specific host. You could also ping a specific host, but specify the actual interface you want to use. Maybe your device has cellular or Wi-Fi or Ethernet, and I want it to just go through my Wi-Fi connection. You can also ping to a specific port. Let's make sure that this thing I can kind of see on my network is, in fact, communicating to the port I want it to. And of course, top. Gotta have top. It's kind of a quasi-top of more Elixir processes, but it's there and you can use it. But hold on, that's not all that there is. Not everything is shell convenience functions. There is stuff like QR encode, which does exactly what you're thinking. Yeah? I'm a slow typer, guys. Oh, why is that there in IX on a Nerves device? I don't know, but have fun. You could do it. how about getting some multicast addresses that your device knows or is broadcasting on? Anybody work with MDNS at all? Man, tough crowd. Maybe the most important thing to remember, if you ever get into a Nerves device and want to see things, log attach. So Nerves, by default, collects a buffer of logs rather than blasting your only access into the device on the console. And log attach attaches to the current group leader of the process so that you get full ASCII glory of all your logs coming in. And then there's the inverse log detach. It's going to be super helpful to have. It's also probably worth noting that although Toolshed was inspired for Nerves, it can technically be used on any IEX session, even on the host. So if it's not apparent, this is on my host starting from the library itself and still getting the same functions. Okay, let's shift gears a bit. Anybody heard of this? Yeah? You like systemd? You're in Linux land, you use it a lot? Well, Nerves doesn't have systemd. At least not the way you think. Your systemd in Nerves is actually the application, or more specifically, it's the supervision tree of the application. So if you remember, we have just the Linux kernel, not the full running operating system, and because Erlang is technically our running system, our running VM that we're doing most of the work on. So if the library, precompiled binary, app, whatever, if it needs to run and it isn't handled by the Linux kernel, then you have to be in charge of starting and maintaining that. Or Erlang, technically, Elixir, whatever your flavor, has to be in charge of this. Now, there are some nuances with long-running processes in Elixir and Erlang, but Frank made yet another library to handle this called MuonDraft. And this isn't the only library or way to deal with processes or daemon-like processes, but it's definitely my go-to, and I just don't even think about it anymore. Specifically for these long-running daemon type, you could configure as a child in your supervisor. This will function similarly to systemd because the application will start it, the supervisor will monitor, and if it goes up and down or just keep getting restarted, it's managed on startup for you. That you could also use, oh, I forgot about them. So we also use this in some of our libraries. Like this is a blurb from VintageNet, in which technologies can use to start a DHCP daemon that needs to run for their networking services. This is a particular helpful function because it just formats the child spec for you to drop it into supervision. Also in Nerves time, which uses MuonDraft to start NTP daemon processes for getting time and keeping time synchronized, because that's a thing. This also passes, in this particular one, some environment variables, because sometimes your running process needs specific environment level data. The main trick to this, actually, when using MuonDraft, might be more of how to interpret systemd files for the stuff that you're used to and the internet only shows you when Googling the things that are broken. And in fact, in this, the most important part is just this line right there. This line shows you how it's expected to start up. And this is what you would have to then transpose or take over into your supervision when starting a daemon process through MuonDraft or making a child spec or whatever. And then for these lines, the unit specifications, we can handle it by just the order we place the target. In the list, you could see that it says we have to come after Baz, so we do come after Baz, and then we have to go before bar, so you get where I'm getting at, right? It's a list that goes top to bottom in order, perfect. Now, I know you might be thinking, oh, shoot, what about this weird out there guy? Well, you might have to go a different route here. So what the wanted by will typically say is basically that foo wants the daemon process when it started as well. And so to maybe a tack that you can take is to guarantee order is to just start them together in their own gen server, maybe. Start them, one right after the other, although this is kind of the same effect technically, but it does ensure that they're running together, where if you put them in the supervision, one may crash and one may still be running, and is that one going to crash or not? Are services going to be broken because it's still running? Like, who knows? This is just an example, something that you can do. There are lots of ways to interpret and go through and maybe adjust this according to how you read the systemd files and how you want to handle those processes in NERV's firmware. Now, most of these that we're dealing with are with a binary or some other program that we've shoved into the release as well. The wonderful Calce. Maybe by adding the binary to the priv directory, and so it's just copied to the build, or it's just a part of the system that's been compiled in. Using pre-compiled binaries like this will work for most cases, but have any of you run into an issue where you try to build a firmware and you get this super nice, wonderful error? Oh, that took a while. Unexpected executable. I'm guessing based on previous answers, it's going to be a pretty astounding no, but let me tell you that this exists and it's super frustrating to deal with. But what this is saying is that you have this cool little binary built for a specific hardware target, or in our case, x86 architecture, and you're trying to put it in a firmware for a different target. But NERVS has a helper script to scrub these mismatches, and it aggressively decides it's not allowed. And it's a very opinionated protection for the user when dealing with this, because they're technically different instruction sets. So maintaining precompiled binaries can sometimes be cumbersome. Maybe you start supporting lots of different targets, especially if you maintain multiple types of systems like x86 or ARM or some off the wall you thought it was cool on eBay or Alibaba, any of those. But maybe you have the source for them. And in those cases, oh, I forgot that existed. It just means you can't run the x86 on ARM. But for those cases, cross-compilation is a great way to go. Hold on, did somebody say, what is cross-compilation? I think so. Yeah. Well, a quick look at Wikipedia will tell you that cross-compiler is necessary to compile code from multiple platforms from one development host. And NERVS is officially supported on many platforms, referred to as systems. In fact, this is the core or a core functionality of NERVS. These systems contain all the tooling for cross-compilation for the system for your development machine. And these systems and all of their tooling are available in nifty little hex packages. And so I want to say here. So these are really integrated in a mix, and they give you a plethora of useful environment variables. You can find your favorite here quick. At compile time that reference specific parts of the tooling that you have cached on your machine, so that when you're compiling an Elixir app, you can also shim in some cross-compilation for your program or binary or source that you have using the expected and supported tooling of NERVS for the target that you're trying to go on, all from your development host. For context, this is an Elixir compilation output for a personal project of mine called Replex. It is a way to replay radio signals on a Raspberry Pi using GPIO pin 4. But this relies on another library that did all the hard work of figuring that out for me and to replay the records of PWM signals, which is called RPI transfer or Ribitix or RPITX, whatever your flavor is. Now this does the compilation of a binary for me. It has all the code. So it is set up with this makefile, which, if you're not familiar with makefile, it's just a nice, easy way to orchestrate some compilation. And this is just a little excerpt from it. Now, the specifics of this file are not that important, except that you can see I use some environment variables here, and these correlate directly to some that NERVS will provide for you if I'm specifying a NERVS target. And these are ones that, well, actually, if we go back to the compilation output, you can see that I am, in fact, through this really long path using actual nerves tooling in part of the project to compile for this specific target. That's pretty neat. I'm going to clap for myself on that one. It's pretty cool. But actually, there's another really important part of this makefile that is the real tip here. And, whoa, what the? I was in the Hyatt app. Okay, does anybody see it? I should have put money on this. All right, it actually is this part right there. And that's because this is declaring a separation of directories according to the mix app path. In tree view, it looks like this. And so, I mean, note this is greatly reduced. Like these trees can be super huge in the build directory. But the important part is that the build is separated by environment and target, and this is done by mix for you. And this is specifically that mix app path seen before, which is set by Elixir make in this case. And by referencing that, we separate all of these build and compile artifacts by the target of which they're being used for. And this is really important because these binaries, like we just said before, are totally different shapes and sets of instructions, and you won't be able to run one on the other without, I mean, maybe, there's always a way. And if you don't separate these resources and these binaries that are a result of the compilation, then you continue to get this error, which is one kind of cryptic if you don't really know what you're doing with hardware or know that instructions are even a thing in files or system instructions. And it's especially annoying if like VS Code is running in the background for you and it just compiles for the host, and all of a sudden you have these build artifacts, you don't even know why they're there. I've obviously have experience, right? Or if you make a library that does this, the most common case we see, somebody builds a library, they add in cross-compilation, and then the first time a user uses it, they make for something, and then it's a total mystery of why they can't recompile a second time. So the golden rule really is to always separate your build files when cross-compiling. Well, we moved fast. We've covered a lot of random tips, and now we'll wind things down a little bit, just get a few last tips in. If you ever find yourself trying nerves, but going through the whole setup to build firmware is too daunting at first, don't worry. Just grab your nerves compatible device. Spend a few hours again searching for that USB dongle you lost. Find that SD card while you're looking as well. That's probably in the same drawer. And download a pre-compiled firmware file for Nerves Lifebook. And the instructions for doing this are on the README here. And is anybody actually, you taking a picture? Are you opening the side? How do you know I didn't rickroll you? We're so trusting here. And you can use tools like Etcher if maybe you're familiar doing stuff with Raspbian OS, or you can use FWUP, or as I like to call it, FWUP, which is the update tool that we use with the Nerves pretty heavily. Plug it in and go, or you can use pre-compiled firmwares from the Elixir Circuits Quick Start, which gives you the pieces for interfacing with I2C or SPI or UART and just kind of dealing with some of the hardware communication concepts. And when in doubt, head over to the Elixir Slack. We're pretty active. Ask questions, bounce around ideas. It's usually a pretty fun place to talk. Sometimes there's funny memes and gifs or cool links, what have you. And, the Elixir forum. We have a Nerves forum as a subset of the Elixir forum, and we try to keep up to date and around there as well. So come join us, lurk, have fun. And if for some wild reason you feel so inclined, this is where you'll find me online. Spoiler alert, I'm super boring on my online presence. I like to live in the moment, you might say. And that's it. Thanks for coming.